All right, so we're going to start now with chapter 10, which is the last chapter we're going to look at in this course. So in this chapter, we're going to look at general equilibrium, which is a more self-contained model than we've looked at so far. So far, we've looked at markets that have just one good. And the trade-off for the consumer was between consuming that one good or having money to spend on other goods. So we call that a partial equilibrium. What that model does is it ignores how one market affects another. So if you have two separate markets, you have two different goods, remember we said we're going to fix prices in all the other markets and we're going to look at just the market for one particular good. So when you do a partial equilibrium, what that does is that it ignores the effects that one market could have on another. So what we're going to do in this chapter is build a more self-contained model where we look at multiple markets, so markets for various goods, and we're going to look at them simultaneously. So this is called a general equilibrium model. Okay, so we'll kind of look at it, we'll start looking at this from the point of view of an example. So let's suppose we're looking at the market for fancy salads. So you can make this fancy salad with either spinach, we'll call that good one, or you could use arugula, or roquette if you prefer. And we'll call that good two. It seems intuitive to me that the demand for spinach would depend on the price of both goods, right? So if arugula got cheaper, you might substitute away from spinach, and vice versa. So the demand for good one, which is spinach, depends on the price of good one, the price of spinach, as well as the price of arugula. Similarly, the demand for arugula is going to depend on both prices as well. Right, so that's what we indicate here. So this is the demand for spinach, and it depends on the price of spinach and the price of arugula. Similarly, the demand for arugula depends on both prices. Okay. Let's suppose that the supply only depends on the price of the good in question. So the supply of spinach doesn't depend on the price of arugula, so it's a function only of the price of spinach. Similarly, the price of arugula only depends on the price of arugula. Okay. So if we want an equilibrium in the market for spinach, of course we're going to set demand equal to supply in the market for spinach. So demand for spinach at the prices P1 and P2 has to equal the supply for spinach at the price P1. Similarly, equilibrium in the market for arugula means that the demand for arugula at the prices P1 and P2 has to equal the supply of arugula at the price P2. So that's what these two equations tell us. Right, so it's clear from looking at those two equations that the final prices and therefore the output in both of the markets are going to depend on what's happening in the other market. So if arugula gets cheaper to produce, then if arugula gets cheaper to produce, then that's going to cause an increase of supply. So what that's going to do is it's going to cause a decrease for demand in spinach. Right? So let's do an example. So let's suppose the demand for arugula and the demand for spinach take these functions, are given by these functions, right? So it's 20 minus 5 times the price of spinach plus 2 times the price of arugula. So notice that there's a plus here, which says that as the price of arugula goes up, the demand for spinach goes up. Similarly, we have a positive coefficient here on the price of spinach in the demand for arugula, so that indicates that these goods are substitutes for one another. Erase that real quick. Now the supply for spinach is just 5 times the price of spinach. Supply for arugula is 3 times the price of arugula. Okay, so now if we want to solve for equilibrium in the spinach market, we just set demand equal to supply. And so demand from the previous slide is this. Supply is 5 times P1, so we just solve this. Of course, we have two unknowns, P1 and P2, so this one equation is not going to be enough, but luckily we have another equation. We have the equilibrium equation for the market for arugula. So the demand for arugula has to equal the supply for arugula. So again, we set the demand for arugula, which we have from the previous slide, equal to the supply for arugula. Now we've got two equations with two unknowns. So we can solve for P1 and P2. Right? So once you solve for P1 and P2, you'll find P1 is 3.4 and P2 is 7. So what you can do then is you can substitute P1 and P2 back into the either supply or demand functions in order to solve for the quantities. So if we put 3.4 back into the supply function, 5 times 3.4, well, we got 17 as our quantity of spinach. And we plug this guy back in here, and we've got the quantity of arugula is 3 times 7, which is the price of arugula, and so therefore we have 21 as the quantity of arugula in equilibrium. Right, so now we've solved for the equilibrium in both of these markets simultaneously. Now let's suppose something happens in the market for arugula. Let's say the arugula producers create some great new fertilizer that makes it easier to produce arugula. What this is going to do is going to shift the supply curve, right? If you remember, this is going to cause the marginal cost curve to shift, and therefore the supply curve. So now we've got a new supply function. At the price P2, rather than 3 times P2, with this new fertilizer, the firms can supply 8 times P2. So that we can now answer questions like, well, what is this going to cause? What's it going to do to the market for spinach? Well, what we can do is go through and resolve for the general equilibrium. We're going to do the same thing we did before. We have the same equation here for the equilibrium in the spinach market, but our equation for the equilibrium in the arugula market is going to change because the right side, which is the supply for arugula, is now different. Instead of 3P2, we have 8P2. But again, we've got these two equations, and we've got two unknowns, P1 and P2, so we can solve both of those. If you solve for P1 and P2, and just like before, you solve for Q1 and Q2, we have new prices, 2.7 and 3.5. And we have two quantities, 13.5 and 28. Now the only thing that changed was the supply curve for arugula. But we see that we have a reduction in the price and the quantity of spinach. Right? The price of spinach used to be 3.4, and the quantity of spinach used to be 17, if I recall. Right? Those have both gone down. Right? But the only change was in the spinach in the market for arugula. So why did this happen? It's because the demand for spinach depends on the price of arugula. And when we have a change in the supply of arugula, that caused a decrease to the price of arugula, and therefore a change in the demand for spinach. So in order to find the equilibrium, we really need to solve for all the quantities and prices simultaneously. So a change in P2 causes a shift in the demand curve for spinach. So that in turn is going to cause a change in the spinach market. So what we want to do is when we are looking at markets that are interrelated, we really should be using general equilibrium approach rather than partial equilibrium.